This is a color detector app made with MIT App Inventor. The app lets you take a picture with your phone's camera and then tap on the picture to identify the RGB pixel value of that location. The basic version of the app can differentiate between red and green, so for example, it could be used by someone who is red-green colorblind. But for a science project, you can expand the app to identify more colors. In the rest of this video, I'll show you how to program the app yourself. If you've never used App Inventor before, you'll need to follow their online instructions to get started. You can also check out the link to the written instructions on our website in the description of this video. For this tutorial video, we're going to start out with a blank project. Again, if you're not sure how to get to this point, make sure you check out App Inventor's online Getting Started instructions. The first thing we're going to do is build a basic camera app that lets you take a picture and display it on the screen. We'll worry about the color identification part later. To do that, we're going to need to add 3 parts to our screen. Make sure you're in the Designer tab and not the Blocks tab where you will write your program later. So over here in the Designer tab, we're going to go to the left menu, scroll down to Drawing and Animation, and click and drag a canvas onto the screen. Next, we're going to scroll back up to the top, select a button, and drag that out. Then scroll down again to Media, and drag out a camera. Note that the camera is a non-visible component, so it will show up down here under non-visible components instead of being displayed on the screen. Now is a good time to start thinking about your app's layout and appearance. Note how the default canvas is very small, and we want to use that to display a picture, so I'm going to make it bigger. I do that by clicking on the canvas, then going over here to Appearance. I'm going to click on Width and set that to Fill Parent, then click OK, and I'm going to manually set the height to 150 pixels, but you can adjust these values to something that you think looks best. I am also going to change the text on my button since the default is text for button 1, but you need the user to know what this button will do. So I'm going to click on the button, and then again over here on the right under Appearance, go all the way down to text for button 1, and I'm going to change that text to Take Picture, but you can call it whatever you want. You can also change things like the size and font on the button. Next up, we are going to go over to the Blocks tab and add code to take a picture and display it on the canvas. So we're going to do that by scrolling down over here on the left, selecting button 1, and dragging out a block for when button 1 click. This will tell the program what to do when button 1 is clicked. We're then going to select camera 1 and call camera 1 take picture. Make sure you snap it inside the when button 1 click block. This will tell the camera to take a picture when you click button 1, but we also need code to display it on the canvas. To do that, we are going to go back here to camera 1 and drag out a when camera 1 after picture block. This tells the code what to do after the camera has taken a picture. We're then going to go to canvas 1, scroll down, there are a lot of blocks here, and drag out set canvas 1 background image 2, and then we can snap on another block to tell it what the image should be. So we're going to drag this out, snap it inside the when camera 1 after picture block, but then we need to tell it what to set the picture to. So we're going to delete this no available assets block, drag that over to the trash can, hover over image here, and drag out a get image block. This will tell the program to set the background image for canvas 1 to the image that was just taken by the camera. You are now ready to test your app. Assuming you followed the setup instructions I referenced earlier and you have the App Inventor companion app installed on your mobile device, you can go up here to Connect and select AI Companion to generate a QR code that you can scan with the app. Once you scan the QR code, you will see a loading screen as the app transfers to your phone. Wait for that to finish, and then you can use the app on your phone. Once the app is open, you should see a simple interface like this. Tap the Take Picture button to open your phone's camera and take a picture. Select OK, and the picture should now be displayed on the canvas in your app. Note that depending on your device, the picture might be rotated by 90 degrees, but identifying picture orientation and rotating it is a complicated problem that we're not going to address in this video. Since ultimately we just need to select a pixel to get the color, it's okay if the picture is rotated for this project. Next, we're going to add the ability to get the RGB color values of an individual pixel in the image. To learn more about RGB color representations, check out the background section of the written instructions linked in the description of this video. For now, head back over to the Designer tab, and we are going to add a bunch of labels, which are features that can display text in the app, but unlike buttons, you can't click on them. We are going to need 6 labels total. 3 of them will just display static text, R, G, and B, and 3 of them will update automatically to display the numeric R, G, and B values when you click on a pixel. The arrangement or layout of these labels in the app is up to you. The simplest approach is just to put them all vertically above each other, but you can go down here to Layout and use different arrangements to also put them next to each other or in a table. I am going to use horizontal arrangements to put pairs of labels next to each other, but again, the layout and design of your app is up to you, so you do not have to do exactly what I do here. So I am going to drag out a horizontal arrangement, put it below the Take Picture button, and then I am going to add 2 labels to that horizontal arrangement, which will put them next to each other. So the names for the labels default to things like Label 1 and Label 2, and the name for the horizontal arrangement defaults to Horizontal Arrangement 1. So as you add more of these, those names might start to get confusing and you won't remember what they're for. It is useful to give them descriptive names so you can refer to them in your program in the blocks editor later. So for example, again, you don't have to use these names, this is just what makes sense to me. I am going to call this first one Red Labels. I'm going to call my first label Red. I'm going to call the second label Red Value, because that is going to display the actual numeric pixel value. But note that renaming the labels is not the same thing as changing the default text that displays in the labels. That is over here under Appearance, just like we changed for the button. There is a text field that by default says text for label 1. So I am going to just change that to R, because I want this is never going to change, it's just going to display R. And then the text for label 2 here is going to update automatically and be overwritten in my program later with a numeric value, so I don't need to change this, but I could if I wanted to. So again, this is just one example of how you can do this. I am now going to duplicate that layout for the green and blue pixel values. I'm not going to record that entire process. It is exactly the same as what I just went through for the red labels. So you can see here, I have finished that process. I have added 3 horizontal arrangements total, 1 for each color. Inside each one of those horizontal arrangements, I have 2 labels, which we can see nested in this list over here. And I have renamed all of them so I know what they're for. So I have my red and red value labels in red labels, green and green value labels in green labels, and so on. And I've also changed the default text for each one, including the value labels, just changing them to 0 so I can see what it looks like when there's a number there. So again, you do not have to arrange things like this, and again, you can control the appearance of everything, changing sizes and colors and fonts and all of that. I am just going with the default values for most of that, but you can customize the appearance of your app. Next, we are going to switch back over to the Blocks tab and write the code that lets us click on the image and get the RGB pixel value of the location where we've clicked. The first thing we will do here is go to Canvas 1 and drag out a When Canvas 1 Touched block. This block will do the code here when Canvas 1 is touched, and it will also get the X and Y, or horizontal and vertical location, or pixel location where the canvas was touched. Inside this block, we are going to create 3 variables to store the red, green, and blue pixel values. We're going to do that by going to Variables and selecting Initialize Local Name 2. this is going to create local variables that are only accessed in this function. We need 3 of them though, so we're going to click on this gear icon and drag out 2 more variables and snap them over here, which is going to give us a total of 3. We want to change the names to things that make sense. So for example, I am going to use red, green, and blue, but you could select whatever variable names make sense to you. Next, we're going to write the code to actually get the red, green, and blue color values for the pixel that has been selected. Now, this is probably the most complicated part of the program, so just bear with me and things will get a little easier. First, we're going to go to Canvas 1 and scroll down to the call Canvas 1 get pixel color block. Note that you could also use the get background pixel color block since all the canvas has on it is a single background image. If there were other things on the canvas, like sprites or animations on top of each other, then getting background pixel color might not give you the pixel color of whatever is in the foreground. But again, in our case, it doesn't matter because we just have one thing in the background. So I'm going to drag out Canvas 1, get pixel color, and for the X, Y location, we want to use the X and Y values that are given by the when Canvas 1 touched function. So I'm going to hover over the X here, and hover over the Y, drag out the get X and get Y blocks, and snap them in here. Note that these have a red X displaying next to them right now because this block is not snapped into anything, so it doesn't know what the X and Y values are. Those will go away when ultimately we have everything snapped in over here, but we have some more blocks to add first. This block on its own is getting the red, green, and blue pixel values, but we want to store those in 3 separate variables, and we need a few more blocks to do that. First, we are going to go up here to Colors and select the Split Color block. Attach that here. Then we are going to go up to Lists and find Select Item in List, which is right here. I'm going to snap that to our split color block, and then we need to add a number for the index. This list is going to have 3 numbers in it. We want to grab the first number for red, then the second number for green, and the third number for blue. So we do that by going here to Math, and just grabbing the very first block, which gives us a constant number, snap that to index here on our select list item block, and I'm going to change that to a 1. So this whole string of blocks here is going to get the pixel color at this XY location and then grab just the red value for that pixel. So we can now finally go snap this over here, and that will give us our red value. And note that when I did that, the X's on the X and Y blocks here went away. Now, thankfully, we don't have to individually drag all of those blocks out again. We can just duplicate this entire chain by right-clicking on the Select List Item block, selecting Duplicate, dragging that down here, snapping it into green, then doing the same thing, snapping it into blue, and for each one, we just need to change the index. So I'm going to change the green index to 2 and the blue index to 3. So now we have code to get the red, green, and blue pixel values for a pixel at this XY location that was touched on Canvas 1, and store those values in variables called red, green, and blue that we can now refer to later in the program. We now have these values stored in variables, but we want to do something with those variables. And remember, we want to update the labels in our viewer to display those numbers. So we're going to go back over to Blocks. And this is where it is very useful to have renamed all of your labels earlier, because if these are just called label 1, label 2, label 3, and so on, it's hard to remember which one you want to change. But since I gave them names that tell me what they're for, I can click on my red value label here and go down to the Set Red Value Text to block, drag that out, snap it in here, and then I want to set this to the variable red. So I'm going to hover over that, get my get red block, drag that out there, And again, now I can just keep going for my other labels, do the same thing. I'm going to set green value text to get green, and I'm going to set the blue value text, if I can get it to snap there, to get blue. So now I should have a program that gets the red, green, and blue values of the pixels and then updates the labels to display those values. So I am ready to connect, scan a new QR code. If you have kept the AI companion open this entire time, it might have updated automatically, but if you let it close or did something else on your phone, you'll need to rescan the QR code, and you're ready to test your updated app. Now, when testing your updated app, you can take a picture and tap on locations in the app to get the RGB pixel values. Doing this just gives you the numeric values, though it does not give you the name of a color, especially for something like a colorblind user who wants to differentiate between red and green. It would be nice if the app actually printed out the words red and green. So that is what we are going to do next. First, we are going to go back over to the designer and add another label. Again, you can put this wherever you want and change its appearance, but for now, I'm just going to put it below my existing labels. I'm going to rename this one and call it color name. Next, we need to add code to make this display the name of a color based on the RGB values, and this is where things get a little tricky. There are over 16 million possible colors in the RGB color space, and not all of them have names. This table shows a list of 16 common colors defined in the earlier days of computing when monitors couldn't display as many colors. However, there are now extended lists with names for many more colors. So for your project, you'll need to decide which colors you want to identify and define ranges to determine what counts as what color. For example, pure red is an RGB value of 255.00, but an RGB value of 254.00 would probably still be safe to call red. In this example, we're going to add some very simple code that does an okay job differentiating between red and green if you already know that an object is either red or green. However, it completely ignores the blue value, so as I will demonstrate later, it can misidentify other colors. It's up to you if you'd like to improve the program to more accurately identify more colors. To do this, we're going to go up to Control and select an if-then-else statement. Add that below our blocks that set the values for the label text. For the condition for this if statement, we're going to go here to to Math, and drag out a comparison block. Change the drop-down menu here from an equal to a greater than sign. We are then going to get our red and green values to compare them. So drag in a get red block and drag in a get green block. So this if statement is checking if the red value is greater than the green value. If that condition is true, it will do something else. If it is not true, it will do something else. So we want to change the text in our color name label. I'm going to find my color name label, the set color name text block, drag that out here, snap it into place in the then part of our if statement, and I want to set a constant text value here as opposed to a variable like we did up here. I'm going to find that under text and just use the first block here to type whatever I want. So if red is greater than green, then I'm going to display red. I'm going to duplicate this block, snap it into the else section of our if then else statement, and change this to green. So what this does, again, is detects if the red value is greater than the green value, it's going to set the color name label to display red. Else, if the red value is less than or equal to the green value, it's going to set the color name label to display green. Again, this is very rudimentary color detection. All it is doing is comparing the red and green values and completely ignoring the blue value, so this is not going to accurately identify other colors, and it will just classify any color as either red or green based on the red and green values. So this could work as a very simple app for a red-green colorblind person who just needs to differentiate between these two colors, but it is not going to name all of the other colors that I showed earlier. After rescanning the QR code and taking a new picture, we can demonstrate this. For example, here I have these colored popsicle sticks again, so I'm going to take a nice close-up picture. And we can see that if I tap the red or green popsicle sticks, the app will correctly identify them as red or green. But again, if I pick any of the other colors, it is just comparing the red and green values. It is not looking at the ranges of those values, just seeing which one is bigger. And it's not looking at the blue value at all. So it will incorrectly identify orange and yellow as red, since the red value is greater than the green value. And it thinks that blue is green since the green value is greater than the red value. So again, not perfect for a general color identification app, but for a red-green colorblind person who can see the other colors okay and just has trouble picking between red and green, this could work as a companion or accessibility app to help them identify the colors. For some more tips about identifying other colors and suggestions for other things you can add to the app, like a cursor that shows you exactly where you've clicked, check out the written instructions linked in the description because I'm not going to go over all of those things in this video. For over 1,000 other projects in all areas of science and engineering, check out our website, www.sciencebuddies.org.